When looking at a numerical expression that involves multiple operations, there is a certain order that we need to follow. As we look at this numerical expression that involves multiple operations, you will see that if we choose to just do the operations left to right by adding first, we get an answer of 25. If we choose to multiply first, we get an answer of 17. Adding first is not the correct answer. Multiplying first is. When we have multiple operations within a numerical expression, in order to simplify it, we need to follow order of operations, which follows the order of Pemdas, where P stands for parentheses, E stands for exponents or any square root values, M stands for multiplication, D stands for division, A addition, and S subtraction. So as we look back at this example, the M in multiplication comes before the A addition in order of operations. So we need to multiply the 3 times the 5 first before we add the 2 to get a final answer of 17. Another way to remember order of operations is, please excuse my dear Aunt Sally. Within order of operations, we are actually able to do multiplication and division in the same step from left to right. The reason why we are able to do this is because multiplication and division essentially are the same operation. For example, 10 divided by 2 is the same thing as 10 times 1/2 or 10 times 0.5. So if I am left with only multiplication and division in my numerical expression, I am able to do them in the same step from left to right. The same goes for addition and subtraction. Once again, they essentially are the same operation. 5 minus 3 is the same thing as 5 plus a negative 3. So if I have only addition and subtraction left in my numerical expression, I am allowed to do those in one step from left to right. Since in both of these numerical expressions, I have multiple operations, including parentheses, exponents, addition, subtraction, and multiplication and division, I must follow order of operation in the steps of Pemdas. In A, I have a set of parentheses. Within those set of parentheses, it is asking me to do 7 minus 2. So that is my first step in order of operations. This results in a numerical expression of 5 squared divided by 5. My next step in order of operations would be the E, exponents. 5 squared is the same thing as 5 times 5. Remember, exponents tell me how many times I need to take this base times itself. So since it is a squared exponent, I'm taking it times itself twice, which results in an answer of 25. My last step to simplify this expression is to do the division, which would give me a final answer of 5. In B, I do not have a set of parentheses, so I can skip that part of my order of operations. Exponents, my next step, there's a 3 cubed. 3 cubed is the same thing as 3 times 3 times 3. My base in this exponential piece is 3, so I'm taking it times itself 3 times because of this exponent, which results in a 27. I must simplify my entire numerator before I'm allowed to divide and simplify this fraction. That is the one difference with order of operations, is that I must simplify everything in the numerator and everything in the denominator before moving on to the division piece of PEMDAS, because each piece of that fraction is like a grouping mechanism, just like parentheses were. So 27 plus 3 is 30, and my last and final step is the division, 30 divided by 10, which results in a final answer of 3. In this numerical expression, I do not have any parentheses. So I move on to the next part of order of operations, which would be e, exponents. 3 squared is the same thing as 3 times 3, or 9. Then I am allowed to do my multiplication and division in one step from left to right. So I can take 8 times 4, which would result in 32, minus 9 divided by 3, which is 3. Then lastly, I can finish simplifying by doing the subtraction of 32 minus 3, which is a final answer of 29. All of the examples that we just previously did were numerical expressions, meaning that they only had numbers within the expression. We can also simplify algebraic expressions, which means that there are variables included in the expression, by replacing the variable with a given number. Then we simplify the expression using order of operations, just as we have done above. First, I'm going to substitute the values of x and y into my expression. This example states that x is equal to 4, so I'm going to replace each x within that expression with a 4, and it also states that y is equal to 3, so I'm going to replace the y value with a 3. This results in the numerical expression of 4 squared plus 4 minus 18 divided by 3 squared. Now I have a numerical expression which looks just like the previous examples we went through, so I can follow order of operations to simplify it. There are no parentheses, so I'm allowed to skip that part of order of the operations. Then I can move on to exponents. There are 2 pieces of exponents within this expression, so I can simplify them both in the same step. 4 squared is the same thing as 4 times 4, which is 16. And 3 squared is the same thing as 3 times 3, which is 9. Then as I move on to multiplication and division, I have one piece of division within this expression, which is 18 divided by 9, or 2. And then since I have only addition and subtraction left, I can do them left to right, all in the same step. So 16 plus 4 is 20, minus 2 is 18. Lastly, we're going to talk about the importance of parentheses within an algebraic or numerical expression. The parentheses are very important. They act as a grouping mechanism. So in the first xy squared, the only piece in this algebraic expression that is being squared is the y. So if we replace the x and y values with 4 and 2, this will result in 4 times 2 squared. In the second expression, where there are parentheses around the product, that means the entire product is being squared. This will, in fact, result in different answers because there are different pieces shown as being squared. In the example on the left, order of operations tells me I need to square the 2 first, and only the 2. 2 squared is 2 times 2, or 4. This leaves me with an answer of 16. In the example on the right, the entire product is within the parentheses, so following Pemdas, I need to do the parentheses first. This leaves me with 8 squared, which would result in a final answer of 64. Much different answers, even though the beginning expression looks very similar. So we must pay attention to the parentheses and see what they are grouping together because they will make a difference.